Okay, let's look at the definition first. Okay, definition of logarithm. So if y is equals to b to the power of x, okay, then log y base b is equals to x. Okay, where b and y are elements of R plus. Okay, so this is what that you must remember. Okay, when given that y is b to the power of x, then we can rewrite this in the form of log. So this b, bring it down here. So log y base b is equals to x. Y base b is equals to x. If you remember and understand this, you can solve a lot of questions. If you cannot do this, you cannot change from here to here, then it's very difficult to solve a lot of questions. Okay. So there are other rules. This is the first one. This is the definition that we must know. Okay. Then there are other rules for logarithm. Okay, log of 1 base b is equals to 0. That means log of 1, any base, for any base is equals to 0. Okay, log 1 is always 0. Okay, third rule, log of b base b is equals to 1. If the base and the number here are the same, then it's equals to 1. Okay, fourth rule, log of b base b to the power of n. This is actually, when you have to the power of n, we can always bring the n to the front here. Okay, we bring the n to the front. So we can write it as n multiplied by log b base b. But because our log b base b is equals to 1, therefore in this case it is equals to n. Okay. Okay, these are the more important laws. Okay, log xy base a is also equals to log x base a plus log y base a. Okay, so log x, well, sometimes the base we don't have to read because the base is always the same. So log xy, if this multiplied here, okay, log xy, it's like this, log xy, we can write it as log x plus log y. Okay, if you have log x divided by y, then this is also equals to log x minus log y. Okay, if you have log x to the power of n, then this is equals to n log x. Okay, this is a very useful rule to solve a lot of logarithm questions. Okay, and the last one is, if you have like this, log c base a, and you want to change the base, you can change the base. Okay, so we can say we want to change to base e, then this equals to log c base b over log a base b. This is how you change the base. Okay, so these are the rules that we are going to use to solve all logarithm questions. I'm sure you've done this before with all this. So just to refresh your memory only. Okay, let me look for a question first. Okay, let's try some examples. If log x base 4 is equals to 2, how do you find x? okay? This is based on the definition, the first rule, okay? Log 4, log x base 4 is equals to 2. From here, we know we can write this as x is equals to 4 to the power of 2. This base here goes up, this goes up to the power. So x is 4 to the power of 2, this is 16. This is directly from the definition, okay? That means if we have log x base 9 is equals to half, what is x? X is equals to
9 to the power 1 over 2.
yes.
9.
What does this mean? What does 9 to the power 1 or 2 mean? What does it mean?
Root of
Root
like
of 9.
1 over 102 means square root.
Root.
Huh? Yes, power 102 always means square root. So this is square root of 9 is equals to 3. Okay. So that's what it means. Huh? This is the first definition. Okay. Okay. Question 2. If you have log 5 base 5 to the power of p, find p. So how do we do this? So this power, you know, you can always bring it to the front. So this is also equals to p log 5 base 5. And you know that log 5 base 5, these numbers are the same, it's equal to 1. So this is equals to p. Yeah, we're just simplifying it here, okay? Okay, so question 3. Log 4x base 2 plus log x base 2 plus 2 log x base 2. Simplify this. How do we simplify this? Okay, so you see here 4x, this is 4 times x. So we must expand this. How do we expand this? So this equals to log 4, 4 times x. 4 times x is log 4 plus log
Log
x base 2, okay? So this is what we get from here, okay? Plus log x base 2 plus 2 log x base 2. So we have log x here, base 2, log x base 2, log x base 2. Can we add all this?
Yes.
What do we get?
4 x base 2.
2, 3, 4. Yes, 4 log x base 2. And we have one here, log 4 base 2. Okay. So can we change this? Can we simplify this?
Equals to 2.
This actually equals to log 2
2 square.
to the power of 2 base 2, right? So this is 4 log x2. So this is log 4 log x plus this 2 bring to the front. So we have 2 log 2 base 2, isn't it? So how much is this? The second part here, how much is this?
2.
2, yeah. So this is 4 log x base 2 plus 2. Okay, so we have simplified it. Can you understand this?
Yes.
Yes.
Can I? Okay, it's question 3. Let's try one more, question 4. Okay. Okay, this looks a little bit long, but it's not so difficult. Huh? 1/3 log plus log a square root of. Okay, when you have a long question like this, the best you must do it step by step. Okay, so let's see if we can solve this step by step. This first term here, okay, this first term here, how do we simplify this?
Bring the exponent to the front.
Yeah, so this is bring this 2 to the front here. So we have 2 over 3 log x base a. Okay. Okay. This second term here, how can we rewrite this first?
Power
Square
of
root
1 over
means
2.
to the power of
1 over 2.
1 over 2.
yes, to the power of 1 over 2. I'll come back next line and solve it. Okay. Okay. This one we have, what is this is x square plus y. That means
Log x
Pecahkan dia.
plus
it's actually log. That means we do this part alone, nah? This one, okay? So this is log x square plus log y base a, correct?
Yes.
is it?
Oh, madam. Madam bukan kalau bracket kita boleh pecahkan jadi tambah log base sama juga eh? Bukan kalau macam tadi for x kan jadi log x base sama tambah log taklah.
What was the law just now?
The log a xy is log a xy equals to log a x plus log y, log a y.
Yeah.
Same.
Itu.
Okay, wait. Huh? So
So it's supposed to be remain, cannot change.
so it's supposed to be
Cannot change. So it
wait.
stays.
So we cannot write it like this, huh? Yeah. So this is x plus y squared to the power of 1 over 2, right? Minus log x squared plus y. Can we do anything with this or not?
No, we cannot.
Cannot, huh?
Yes, cannot.
Okay. Let's continue with this first. Sorry. So this is 2 over 3 log x a plus half log x plus y squared a minus log x squared plus y a. Okay. Okay. So can we further solve this or not? Can we further simplify this?
Sure.
I don't think so, madam.
So it doesn't look like there is a solution here.
No.
Okay. Okay, it's good that you realize that this one cannot break up anymore. Okay. Okay, so I think this is where we stop. Anyway, this question I'll come back to you later, okay?
Okay, madam.
Okay, so I have one more question here, question 5. Okay, let's see this. So log 8x to the power of 3 over 2y. Okay, let's simplify this. So we have log this over this. So that means 8x cube base 2 minus, right? Log 2y base 2. Okay, now this one still a combination of terms. So we can break this up. How do we break this up? We break it for this is x cube. The cube is only for x. It's not for 8. Okay. We can either break it up separately now or we can change this to the power of 3. We try to break it up separately. Okay. So this is log 8 plus log x cube base 2 minus this is log 2 to the power base 2 plus log y base 2, correct?
Yes.
So a is 2 to the power of Later you
3.
can do it fast, okay? Just for this lesson, I'm doing it slowly, okay? So this is minus log, this is minus and plus will be minus log y2. So now let's solve it. This will be 3 log 2 base 2 plus 3 log x base 2 minus log 2 base 2 minus log y base 2. Okay, now you solve it. We have 3 log 2 and we have log 2. So what do we get? 3 log 2 minus log 2?
2 log 2
Yes,
base 2.
2 log 2 base 2. And then we have x and we have y. Yeah? So the x and y we cannot solve. So this is 1. So this is 2 plus 3 log x base 2 minus log y base 2. Okay? Of course, as you're doing later, you can skip a lot of steps. Huh? Okay, so this is these are examples using laws of logarithm. Okay, so we have finished with this, and we have one last thing to do. Calculations using logarithm. Okay, for calculations using logarithm, I'm going to give you one example. Okay. These are difficult calculations that without using logarithm it's difficult to do, like this. Okay, for example, 5 times 3 to the power of t is equals to 20. Find t. So what do we do? First step.
Log.
Before we do log, let's simplify this. So this is 3 to the power of t is equals to this 5 here. Bring it on this side. It will be 20 over 5. So 3 to the power of t is equals to 4. Okay. Now we do take log. So how do we change this log?
Adding log.
Uh,
Log.
you want to add log, or we can straight away use the log definition. If we use the log definition, then we have log 4 base 3 is equals to t. Straight away we have this if we use the definition of logarithm. Okay, all right. So therefore I like to write it this way again. Okay, so we can't solve it. Can you solve this using your calculator? Can you find this answer using your calculator or not?
Yes.
Yes.
Okay, what's your answer? Tell me.
The
Anyone?
one 1.26185.
Yeah, so it is equals to 1.262, correct? 26 again
Yes.
18.
Yes.
261
26185.
so 19. 2619, correct? Okay.
Yes.
For
Yes.
logarithm, we always give to 4 decimal places. So this is your answer. So you can use your calculator straight away and get your answer. Okay. So this is how we can solve a calculation that is no logarithm using logarithm. Okay. Okay. Question 2. Okay. Okay, how are we going to do this if you're not going to use the calculator in the first step, okay? Okay, if you're not going to use calculator in the first step, how do we solve this? Okay, for questions like this, we add log on both sides. We take log for both left and right. So log n. When I write log n, I actually mean log base 10. Okay, so this is equals to log of this whole thing. Okay, so log n is equals to, when you have this times this divided by this times this, it actually means log 647.32 plus log 0.0000147 minus log 8.473 minus log 64. Correct? Yes? Up here is times, log this times this. So you change to log this plus log this. This whole thing divided by this. Divided by this means the top minus the bottom. So this one will become minus here. Okay? So from here, if you use your calculators to find the values of all these, so you have to, you can check with me now. Okay? You can check if these values are correct. This is negative 5.8327 minus 0.9280 minus 1.8062. Okay, so from here you get log n is equals to negative 5.7558. Okay, if log n, so this is actually base 10. If log n is this, therefore n is equals to 10 to the power of negative 5 based on the definition for logarithm. N is 10 to the power of this. Okay, and from your calculator, now you can calculate the n is equals to 1.7547 times 10 to the power of negative 6. And that's your answer. Okay. If you're given a question like this to solve, you must show the working, how you get the answer. We cannot just key in everything to a calculator and get our answer here, okay? So we cannot do that. We have to show how we actually solve this. So the easier way to solve is to use logarithm. Questions like this, you must take log for both sides. When you say log, it actually means base 10, okay? Unless they give you a base. Okay. Question 3, yeah? Okay. How do we find this? Find the value of this number. Okay. We want to show the working. How do we do it? So we start with let n is equals to this. Okay. So that we can take log on both sides. 1, 2, 3, 4, 5, 1, 6, 5. Let n is equals to root 5 of this number, 0.0000165. Okay. So now that we have written this, we take log both sides. So log n is equals to log of this number. Okay. Okay. Now how do we do it? Let's solve the right hand side first. So what does this mean actually mean? This means log of
1 over to the power 1 over 5.
yes, correct, to the power of 1 over 5. So this is actually can we write this in terms of multiples of 10? How do we write this in terms of multiples of 10? This is 1 point 1.65 times
5, 10,
10 to the power
of
negative 6.
yes, 10 to the power of negative 6. And then the square root we took off, so we write here to the power of 1 over
5.
5. So now how do we solve this? Because this is log, we can bring this power to the front, okay? So 1 over 5 log 10 of 1.65 times 10 to the power of negative 6. Now, this is times here, times. So, what is it equals to? So, it's 1 over 5 log 1.65 plus log
10 to the power of
10 to the power of negative 6. So, this is equals to 1 over 5 log 1.65. Here is negative, bring the negative 6 to the front, negative 6. What is log 10? This is
1.
actually how much?
Log 10, 10, 1.
1. Yeah, so we have 1.5 log 10, 1.65 minus
Minus 6.
minus 6 over
over
5. Okay, so we
Oh,
using our calculators, we get this is negative 1.1565. Okay, so therefore log 10, log n is equals to negative 1.1565. So n is equals to 10 to the power of negative 1.1565, and this is 0.06974. Okay. Okay.
Madam,
Yeah.
jadi kalau macam equation tu dah tak boleh simplifikan lagi baru kita tekan calculator
When you come to the last langkah, because you cannot find it any other way. You cannot find the answer any other way, then only you use the calculator lah. Okay. Until then you must show how to use log lah.
Alright, understand.
Okay. Okay, just now was question 4, I think. Find 2 to the power of 3, 4, 5. Can you do this on your calculator? Can or not?
Bad error.
No.
Cannot, isn't it? Okay,
Yeah.
so it cannot miss. There's no other way of doing it. So we have to use log. So how do we start this? How do we start to do? How do we write here? Let n, you can use any alphabet. Let n is equals to 2 to the power of 3, 4, 5. When we say like this, next step is, so take log. Log of n is equals to log of 2 to the power of 3, 4, 5. Okay, so when we add log to the left hand side, we also have to add to the right hand side. Okay, then we solve the right hand side first. So how do we solve this? This is power. So
3, 4, 5. Log 2
times
base.
log 2. Okay, so this is log 10 n. So what is log 2? Use your calculator. What is log 2?
0.3010.
Yeah, 3010 times by 345 is 103.8553. Okay, after this, how do we do? This is now we are back at the definition of log. So therefore n is equals to, this one will go here and this one will go to the power. So n is equals to 10 to the power of 103.8553. Can you find this in your calculator?
No. Still.
Can or not?
No.
Cannot. So what do we do now? We cannot find this big number on the calculator, but we can break this number, right? This is also equals to 10 to the power of 103 times 10 to the power of 0.8553. Now this one you put in your calculator. 10 to the power of, what do you get?
7.1664.
7.1664 multiplied by 10 to the power of 103. That's your answer. Okay. So this one, a lot of the steps we cannot use a calculator. Okay. So only where you can use like log 2, you have to substitute the value. When you come to the last part, since you cannot find such a big number, you have to break it up. Okay. So these are calculations which we can solve using logarithm. Okay.